welcome Michael Folkson. He's going to be talking about the impact of Schnorr, Taproot, and Tapscript on Lightning.
Cool, thank you. Okay, so I'm Michael Folkson. I'm organizer of London Bitcoin Devs. I'm going to try and speak as quickly as Lalu does, but I'll fail. There's been tons of good presentations over the last 2 days, but they have to be 20 minutes. So as organizer of London Bitcoin Devs, I'd like to invite any of the speakers who'd like to do extended presentations to come to London and speak at our meetup. I thought I'd better start with this because I think we're all getting very, very enthusiastic about what we can build on Lightning and all the amazing use cases, but we do need to remind ourselves of the importance of that base layer. And without that base layer, we just don't have any security if that base layer fails. So we need to remember that at all times. There's tons of work still required on that base layer on Bitcoin Core in terms of modularity, in terms of various features, integrating hardware wallets, etc. And so I would encourage anybody who's getting really enthusiastic about Lightning to still monitor what's happening on that base layer, what's happening in Bitcoin Core and BTCD. There's a Bitcoin Core PR review club. There's tons of work and contributions needed on that base layer, and that will be the case for a very long time, in my view. Obviously, scaling and privacy are massively impacted by that base layer, and some of the functionality that we want on Lightning, L2, Neutrino, fee estimation, and scripting are all going to be impacted by what the current state of the base layer is and how it will change over the next few years. So I'm going to be talking about Schnorr and Taproot. So a very, very quick discussion on community consensus. I think the block size war has really left the Bitcoin community and Lightning community pretty scarred in that we're not having the same discussions that we perhaps would have done had it not been for the block size war. I think we're kind of just leaving it to the wizards and not really challenging them and trying to understand what the proposals are trying to achieve and whether they can be improved. So a couple of things on community consensus. Soft forks are not regular occurrences. We need to be sure as a Lightning community what is in these soft forks and what isn't. And if we are to obtain consensus on future changes to that base layer, we do need Christian Decker levels of persistence. I talked a bit about the block size war. I don't want to talk about that because I don't have time. It's not really interesting. But it was only 2 years ago, which is really, really surprising. And it was the massive argument was over a 2x block size increase. So if we move on to today, Matt Crollo at Breaking Bitcoin said, we don't know if Lightning results in scaling Bitcoin 10x higher or 1,000x higher. It's probably not 10,000x higher, but we just don't know. If we compare these multiples to the multiple of 2 that caused such chaos and fracas in 2017, it just shows how far we've come and how insignificant that argument really was. So I don't know where everyone is in terms of technical understanding. I thought I'd briefly talk about a 101 on Bitcoin transactions and Lightning 101. Bitcoin transactions are just a bunch of inputs and a bunch of outputs. The inputs need to be unlocked. There's certain conditions. Normally the condition is provide a signature proving that you own this public key. And then once you're able to unlock those conditions, then you can impose new conditions. And so those are the outputs. It's just unlocking, locking mechanism. That's effectively what every transaction is. Digital signatures, I'd encourage you, if you're an aspiring developer, to try out Justin Moon's course. He talks about PNG coin and digital signatures and the difference between physical signatures and digital signatures. Digital signatures are amazing creation, in summary, because rather than just creating the same signature over and over again, every signature is different. You're proving that you own the private key, but you don't have to announce what your private key is. So the world never finds out what your private key is, but you're proving that you own it, and that's just such an amazing creation. Okay, so BIP Schnorr. A small benefit is that Schnorr signatures are a little bit smaller than ECDSA signatures. That's not the key motivation for bringing in Schnorr signatures, but it's worth mentioning. One of the key improvements with Schnorr is that we have these unfairly linear signatures. Now, the beauty of these unfairly linear signatures is that you can aggregate keys and aggregate signatures And so for, say, a multisig, rather than publishing or broadcasting every key and every signature on chain, you just have to publish one signature, and so there's massive space savings, and it's really great for privacy. So I used to call this signature aggregation. Jonas scolded me, and I'm now calling it key aggregation. But it's an aggregation of signatures, and they map to an aggregation of keys. Another key benefit is batch verification. So this is, rather than reducing the number of signatures that go on chain, there's a number of benefits of batch verification in that the same number of signatures go on chain, but you're able to verify that these signatures are valid in a considerably shorter amount of time. So these are some of the benefits that come with Schnorr. I'd encourage you, if you haven't already, to watch the presentation from Elikai. I thought it was a really good intro to the difference between ECDSA and Schnorr. Basically, most of the stuff isn't changing. The elliptic curve, for example, isn't changing, but the formula for how a Schnorr signature is calculated is changing. And it's simpler, and it's a lot easier. It's more linear and a lot easier to aggregate keys and aggregate signatures. So those are the only formulae that are in these slides. But I think it demonstrates how Schnorr is simpler and easier to understand and easier to use some of the features. Okay, so then combining Schnorr with Taproot offers a lot more benefits. So, introduction to Taproot, it's a SegWit version 1 output type. SegWit introduced script versioning, and this is the first new version using SegWit versioning. The key beauty of Taproot is that, and Mast has been talked about a lot, but with Merkle trees, you're able to put a lot of alternative script paths within the tree, and then, so pre-Taproot, the whole script went on chain, and all the alternatives were published on chain too. With Taproot, a Merkle root goes on chain, and then there's a bunch of different scripts below that root, and you only need to put the script that you're actually executing on the chain. So again, great for privacy and tons of space savings if you have a really complicated script with lots of alternative script paths. This is a diagram to try and help you visualize it, because the key difference between Mast and Taproot was that now you do have the alternative of paying to pubkey in addition to paying to one of the script paths within the tree. So a lot of the time, you're just going to do that simple pay to pubkey spend, and so you don't really need to bother about all those complicated leaf scripts and alternative script paths in the tree. But if you do have a complex script, then you just have to reveal the script that you're actually spending from, and so this is typically one particular leaf within a Merkle tree. We should all be familiar with Merkle trees because they're used in block headers, and transactions are all hashed into a Merkle tree, and the Merkle root goes on chain in the block header. So this is using Merkle trees again, and this is a really neat feature. Okay, Tapscript, there's a few changes to Bitcoin script coming. Check multisig is going to be disabled, and the replacement is going to be called checksig add. One of the reasons for this is check multisig, where when you are verifying the different signatures for the different keys in check multisig, you don't actually tell check multisig which signature maps to which key. So what it has to do is try to verify a particular signature for a key. If that doesn't work, you try the next key. If that doesn't work, you try the next key. And so that's pretty inefficient. With checksig add, you are actually telling the opcode which signature maps to which key, which public key. And this means that it's a lot easier to do that batch verification that I was talking about earlier. There is a new public key version, and perhaps sig hash no input could be introduced as that new public key version, although there's lots of discussion about that. Okay. So I think we all know how Lightning works, so I don't need to do the Lightning 101. But very, very briefly, there's a funding transaction. You're funding a 2 of 2 multisig. And then there's different ways that the channel can be closed. Generally, there's the cooperative close, and this is just, I provide a signature, I ask the remote parties to provide a signature, 2 signatures go on chain. if that's all we had to do, it would be a very, very simple protocol, and we probably wouldn't need a conference. But all the complexity is in the unilateral and the force close and the justice transaction. So this is ensuring that if the remote party isn't responding, I can still close the channel with a time lock, or if the remote party tries to cheat me, I can still recover my funds, and so this is trustless or trust minimized, and that's where all the complexity of Lightning is. So if we think about how the Lightning scripts are going to change after Schnorr and Taproot, the script for a funding transaction is what's on screen now. It's pretty simple, using check multisig, and you're verifying that the two signatures are valid for the two public keys. With Schnorr and Taproot, as I said, you will be aggregating the two public keys, aggregating those two signatures, and then only one public key and one signature will need to be verified from that funding transaction. The force close, or the unilateral close, has a more complicated script, and this is where the Taproot tree can come in. If you see on the screen, there's two alternative paths. There's an if statement and then an else statement. One of those if statements can be one branch, and the else statement can be another branch, and so that's actually utilizing the Merkle tree structure that I was talking about earlier within Taproot. Mostly, Lightning doesn't take advantage of that Taproot tree because if you understand how the Lightning protocol works, it's like the justice transaction spends from that attempted cheat transaction. So it's like different transactions rather than trying to incorporate loads of script paths within one transaction. But this is one example where that Merkle tree structure can be used within the Lightning protocol. If you're less interested in scaling and you're really concerned about privacy, there are a bunch of benefits for Lightning from Schnorr and Taproot. As I said earlier, the channel funding transaction under Schnorr Taproot can't be identified, the cooperative close can't be identified, and if one of those two conditions in the tree are spent, you only have to reveal one of them. And so that saves some privacy in terms of laying out the whole complicated Lightning script in the case of a unilateral close or a justice transaction. There are possibilities that Lightning scripts could change in future, and with Taproot, there is the possibility that we could look into alternative channel close paths. So this is a tweet from Alex Bosworth that I found really interesting. At the moment, if your peer is unresponsive and you initiate a force close, you're effectively betting that the peer won't come back online. So there's an alternative script path that we could potentially add in future, or people could use in future, where you would have the option of if you tried to force close and there was the unilateral close, but your peer came back online, you could then use that alternative channel close, taking advantage of the fact that your peer is back online, so then you don't have to wait for that time lock to receive your funds. So there are lots of exciting possibilities in terms of alternative channel closes in future. Another key one is adapter signatures. Adapter signatures, in really simple terms, is taking advantage of that linearity property of Schnorr, where you can, the basic explanation of it would be Schnorr subtraction, where you have an invalid signature, you use the secret to subtract from that invalid signature, and that creates a valid signature. So there is the possibility, and it's being discussed at the moment, that HDLCs will lose HDLCs, and they'll be replaced instead by adapter signatures. So if you spent lots of time understanding how HDLCs work, that might be a little frustrating for you. But, and it will be sad to see them go, but adapter signatures are potentially superior, yeah, so that'll be an exciting development to come in future. And then, so if we go back to that macro of like how far do we think Lightning can scale Bitcoin? One of the key potential successors to Taproot. There's other candidates for future soft forks, including the Great Consensus Cleanup and various others. But maybe in 2025, someone told me yesterday, maybe 2030, we could have a successor to Taproot where rather than having key aggregation and signature aggregation within one input, we could aggregate all of those keys and all of those signatures across input. Now this is really cool because this allows you to open and close tons of channels in one transaction with only one signature going on chain. So in terms of scaling, so it's great for privacy, but in terms of scaling, that just really ratchets up the potential of Lightning. And so hopefully at one stage we'll get it. I think Jonas told me in a conversation he's sure we will get it eventually, but we have no idea when. And there's still tons of work to do on Schnorr and Taproot, so let's not get ahead of ourselves. So big picture, how much time have I had? Okay, so this is where I think we are in October 2019. There's still, as I said earlier, there's still tons of work to do on that base chain. There's tons of work to do on Bitcoin Core. Lally would love people to help him on BTCD. So we really can't forget about that base layer. There's still so much work to do on that base layer. It's great that we're building all the Lightning stuff and all the projects are really, really exciting. And so 2029 or whatever the time is, like we can really dream about those skyscrapers. But we can't really get ahead of ourselves when we're still ensuring that those foundations are strong. And as I said earlier, without those foundations, without that base layer, like we're all going home and this conference is over. So as I said, I run the London Bitcoin Devs group. If you're an aspiring developer or would like to learn more, there's tons of resources online. There's tons of great books. Justin Moon has a great course. We have Socratic seminars. We have meetups. We have Bitcoin Optech. So I'd really encourage you to learn more, delve deeper into this stuff, and ensure that it's not just a small group of wizards telling us what's good for us, that we're actually challenging them and ensuring that the code that's merged into Bitcoin is optimal. Okay, I don't know how much time I have, and I want to pass on to Jonas, but does anyone have any questions on the basics of Schnorr and Taproot? Hopefully that was helpful. Yeah.